We're going to try to find the momentum of the objects, and they should be the same. And momentum is signified by letter P, and is equal to the mass times the velocity of an object.
Impulse is equal to the force times delta time, which is the force applied over a certain amount of time.
Impulse, or F delta t, is equal to the change in momentum, which is momentum final minus momentum initial.
So for this experiment, we'll be using this equation, which is a derivation of the impulse momentum theorem. This represents impulse, F delta t, or force times change over time. And this represents the change in momentum, Pf minus Pi. And so this equation can be rearranged to show that the force is equal to the change in momentum divided by the change over time. Since the change in momentum are the same, and the F is the same, or the F is a constant for both objects when they're thrown, the delta t is the only variable that changes. So when delta t changes and is greater, and the momentum is constant divided by a greater delta t, the force acting on the object is lesser. And when the delta t is lesser and the momentum still stays the same and divides by a lesser delta t, the force acting on the object is greater. So when we throw an object at the wall, it will break because the delta t is much smaller, and the force acting on the object will be greater. And when we throw it at the sheet, the delta t will be much greater, and the force acting on the object will be much smaller. So this is our short time change water balloon. We decided to use water balloons rather than eggs because they are easier to clean up. 3, 2, 1. So as you can see, this water balloon, which had the shorter time change, had the greater impulse acting on it when it hit the ground, and thus it is broken. This is the long time change water balloon. When we throw it at the jacket will soften it and make sure that it has a longer time of impulse. As you can see, the water balloon is not broken.
To recap, the first balloon popped because the delta t was much shorter, therefore the force was greater exerted by the ground on the balloon, and it popped.
Okay, so the second balloon did not pop because there was a greater change in time, resulting in a lesser force.
Three, 2, 1. Ah, dang it.